while you're doing that, I'll just talk a little bit about a bit of what we talked about yesterday. So remember yesterday we were looking a little bit at the parent constraint. So the parent constraint, if you recall from the talk, basically allows us to connect two objects without putting them together in a physical hierarchy. So for example, if I have two spheres, and traditionally so far we've been just grouping things together or just parenting things together so they move as one object essentially. With constraining though, which we're going to be talking about more after the break, basically this allows us to do the same thing, except it allows us to keep the objects separate. So they're not physically connected like the one above are, right? So they're completely separate objects. So I can go in and move something around and it will behave as if they're connected. Now there's a couple different types of constraints and they do things a little bit differently. So the one we were looking at yesterday basically is controlling the child object, or the object being controlled, through its translation and rotation values. Now there's a whole bunch of other constraints if we look at this here from this constraint list, and for the most part they do the same thing. They're going to be controlling rotation values and translation values, but they're going to do things in a little bit of a different way, controlling them a little bit differently. So if we were to look at these here, let me just create a better object to demonstrate. Oh, is it there?
Yeah, on the rigging folder.
Okay, perfect, thanks. So what I'm going to do is open rigging.
Dropbox.
Cool. So we get into more complicated, when we get into more complicated things, for example here where we have, a series of pistons that need to kind of move around, where we have this kind of arm set up, where, they need to be able to move around and twist and things like that. It gets a little bit more complicated. So it's not something that we can just parent to one or the other, because they're not just they won't move like that. It's going to be kind of all to one or all to the other object, in this case all to the arm control or all to whatever's controlling the head. So what we could do is create a situation where these piston shapes exist outside of the hierarchy of both the arm skeleton and the body skeleton, and basically using both sides to drive various components essentially. So let's take a look at this, just as a little bit of abstract perhaps. So I'm just going to start by just creating a very basic shape here, and not necessarily a piston, but let me just reduce this down a bit. And free strands, history, okay. All right, so we've got these two shapes. So as I was mentioning, there's a bunch of different types of constraints that we can use here. So the parent one, parent constraint, acts just like parenting an object. The only thing it doesn't do with the parent constraint, so it does translates, it does rotates, it doesn't do scales. So it won't scale the objects together as a default. I could do this, and add what's called a scale constraint, and then basically it'll act and behave as if all of those elements are connected. But we'll save that one for later. But let's look at some of these other constraints. So the parent constraint does both. It does translates and rotates, and basically the child will translate and rotate from the parent's pivot point. And that's kind of unique to a parent constraint. What's different from, say, maybe adding some of these others in combination. So it's quite different in that regard. Then we also have, starting at the top here, we've got what's called a point constraint. So this is another transformation or translate constraint. You can see here, as a default, it snaps over to the pivot of the other object. So all of these constraints, if you go into the option box, will give you this option here, maintain offset. With the parent constraint, this is on as a default because it's like parenting. So it's going to connect it without moving the child. A lot of these other ones might have this turned off, maintain offset. And basically that's just maintaining relative distance between the two selected objects that we're constraining. So in this case, I'm going to make sure this is on for each of these examples. So I'm going to go apply. So as you can see here, that the child is what gets the constraint node. I know there's a constraint node here because these values are blued out. That indicates a constraint is going into those channels. You'll also see the constraint node under its shape category here. And if we look at it in the outliner, or you can do another, well, not to be confusing, let's just do the outliner. If you look at it in the outliner, you'll see the constraint node on the geometry there. You can delete a constraint just by deleting that constraint node, and that will remove the constraint. You could break a constraint by selecting the actual attributes that it's connected to and breaking selected or break connections. But as you can see, that's not, even though it's kind of breaking the constraint, it's not removing that constraint node. So that's going to become kind of a junk node in your hierarchy. So the better way, if you do want to remove a constraint, is actually just select that constraint node and delete it. You don't have to do it in the outliner. I mentioned this the other day. Constraint node exists beside the shape node of an object, so it's a sibling in the hierarchy. So all you have to do is hit the down arrow and left or right arrow, and it'll come up with the constraint node, and then you can just delete it there without even opening the outliner if you wanted to. But you got this node. So going back to this type of constraint, the point constraint, basically, you know, so far it looks just like a parent constraint. It's going to move the objects around. The difference, though, is that it doesn't deal with rotations. So it's only going to translate the object. It's not going to rotate the object. Then we have what's called a rotation constraint or an orient constraint. Skipping the aim, we'll come back to that in a second. And what the aim constraint does is it doesn't translate the objects, but it will match the orientation. So right now, and it's going to be based off of the pivot of the object. So if this pivot is inverted, then it's going to move opposite in one regard. If I want to do an exact mirror, I have to make sure their axes are exactly mirrored to one another in terms of, if we were to actually look at these these axes, well, it looks like they're actually pretty much the same. But I would actually have to invert this guy to get a mirror copy. Let's see. Bear with me for a sec. Yeah, so you would just have to make sure the pivot, if I did want to do an exact mirror move, I would just have to make sure the pivot is aligned properly. Because technically this is doing the exact same rotation, right? If I rotate this down, this part is going to be pointing down, this part's pointing up, this part's pointing down, this part's pointing up. So it is giving me the exact same rotation. It's just that it's rotating from a different pivot on this object because they're facing toward each other. So it's a little bit of an abstract. If I had two objects with the exact same pivot and did the same thing, it's going to match exactly, right? So it really depends on the orientation and the, because I did invert this and then I froze trans, so it's a little bit different, but it will match exactly the orientation, but it doesn't do any kind of scale or translation. Now you could do both an orient and point constraint, so it does translate and it does rotate, but it's a little bit different, as you can see, from a parent constraint. Because with a orient and a point constraint, the pivots stay relative to each object, essentially. Whereas with a parent constraint, basically this object uses this object's pivot for the rotation values. So it acts like more like a child in a hierarchy, essentially. So it's a little bit different in terms of how they do the same thing, essentially. Well, different things. Now this is all cool stuff. But how does this help us for doing something like, say, like a, like a piston, where basically I want to be able to move something here, and I need to make sure that these are always aligned to one another, so that when things are moving in and out, it's always moving in the exact same axes. So we also have this other type of rotation constraint, which is cool, and that's this guy, the aim constraint. And if you're using, say, for example, Davey, his knee and elbow controls, I don't know if you noticed, they're always kind of pointing in the direction. The knees are pointing in, or the eye controls, when you move them around, the eyes kind of are always following the eye controls. So that's connected using this guy, this aim constraint. And basically, whatever you've selected will always look at the other object, essentially. Now, we do have to align it. I'm not going to worry about the different aim vectors at the moment. What we're going to do instead is just turn on maintain offset for this. And that way we don't have to be too specific until next term. So basically, your parent, when I move this around, the child is always going to follow the direction of that. So with a piston, well, that's cool for one side, but what about this side? This is going to get all broken if I'm trying to move that like a piston. The cool thing with a constraint is you can just invert your selection and do the exact same to the other side. So when I'm moving this around now, these will always face each other, right? Both of them will face each other. So it doesn't matter which one I grab, they're always going to kind of be aligned properly, which is cool. Which is basically what's happening over here, right? So this guy is constrained to this guy, and this guy is constrained to this guy, using the orient constraints, which is pretty straightforward so far, right? And that works. So now how would we apply this to something that's going to have like an arm control, for example, where I need to be able to rotate that and move that around? There's a skeleton. If I were to bring up the skeleton for this guy, we have a body skeleton, we have an arm skeleton. How am I going to connect all this together? Well, with joints, for one. So I know that my alignment's all set properly. Well, technically I don't even have to align it originally because of the way this is going to work, which is cool. But I'll show you this in a second. But basically, if we're to look at the skeleton, each kind of ball socket for each of these pistons, because it is kind of a ball socket joint at the base of these, has a joint that is snapped directly in the middle of it. Let me activate my joint so I can select them again, so just bear with me. So display, drawing overrides, and just turn that off. There we go. So each of these rotating points has a joint directly in the middle of it. And as I showed you guys yesterday, I aligned that just by using a point constraint. So I took, you could use a parent constraint, but that's fine. I just used a point constraint. So I'm gonna set this up, just one piston, for example. So let me just grab a cylinder. And I'm just going to do a very rudimentary one for this. So I'll grab another cylinder. That's going to be smaller. And then at the base of these, each of these will have a sphere. That is going to pivot over. All right. So these are going to be the pivot points, and then so even if there's an angle, it doesn't really matter if you freeze transformations. The key thing, though, is to make sure your pivots are always aligned to the center of your object where you want things to move from. So I'm going to freeze trans, delete history. I could even, like the arm here, kind of move things around and rotate them into position if I needed to. So I'm going to group it to itself, maybe center pivot on the group, but not center pivot on the geometry itself, because that would mess up my pivot points. So maybe I'll just kind of move it like this. And then what I'm going to do, so it's all misaligned. This is all zeroed out, though, obviously. Even though it is angled properly, because when I move the group, all of this stays relative. So it is angling down the joint, but that doesn't matter. I'm not going to use any of that information anyway. So first thing I want to do is create my joints for the piston. So I'm going to go in and use my skeleton tool. And I'm just going to create 2 joints. 1, 2. All right, they don't have to be anywhere. They're just aligned to nowhere. And what I want to do is I want to snap each of these to the pivots of the rotating object, in this case the sphere. So I'm going to select the sphere, or whichever object has the pivot I want to use, select the joint, and I'm just going to use a point constraint with maintain offset off, so that it just snaps right directly into the middle. As I mentioned, the alignment doesn't matter yet, because it will get aligned once we add in our constraint. Because remember, an orient constraint will automatically make it look at each other, so it'll automatically align to one another. So I'm going to go and select the other point, the other joint, and go point constraint. There we go.
Do you need to delete them afterwards, the constraints?
You do. So we're just using those constraints strictly for for snapping them to the center of those objects. So we don't need them after that, so I'm just going to delete them. So I'll just call this left, and I'll call this right for now. But you could call them lower piston, upper piston, whatever you want that's relative to the geometry.
Alignment to the center of the object or to the pivot point?
To the pivot point. So if you look at these, they're aligned to world space still, right? So up and down. So one thing we don't want to do yet is connect our geometry to them, because we do want to align them, and if we connect the geometry to them first, and then we align them after, the geometry is going to get all kind of messed up and moved around. So I'm going to align them using this exact same thing I just did here, right? This orientation. So in this case, and we're going to do both, so it doesn't matter which one you do first. I'm going to select left and right in that order, and then right and left afterwards, but it doesn't matter which order you go with first. And I'm going to use the aim constraint. Now this time I want to turn off maintain offset, because I don't want the joints to keep the orientation they're on. I want them to actually align perfectly to one another. Now technically it doesn't matter, because once they're aiming and you connect your geometry to that, it's going to behave and move the way it should anyway. But just to be sure, I just want to make sure it's aligned exactly to one another. So what I'm going to do is maintain offset off and go apply. And you can see that that's now snapped and aligned perfectly along that geometry. And then I'm going to do the same thing over here with the other one. So I'm going to select the right one first, the left one second. Just remember this, the last one selected will be the child. And I'll go apply. There we go. And I'm just going to connect my geometry to these guys, and I'm going to connect them with a parent constraint. So I'm going to select my joint, select the geometry, similar to what we did yesterday, and just use the parent constraint. And then I'll just do the same for this guy. So now when I move my this side over here, it's going to move well, I can keep moving it indefinitely, but you know, as long as I move it within a certain range or a limit that we're going to set, it's always going to stay, or that piston's always going to move. And if I move the other side, not the constraint node, if I move the joint, this is going to move. And it's going to move in any angle, right? And stay connected. So that's going to move and work properly. And same for the other side. That'll stay and move properly as well. So far so good. That's pretty straightforward, right?
Yeah.
Now, what you need to do though is, how do I connect this into the rest of the rig? And that's pretty easy as well. So you just have your arm and you have your torso. So let me just create two chains here. I think that's it there. So you have your arm, you've got your torso, whatever number of joints you have for that. Let me just move this into place here. Okay. So when you're connecting, as I mentioned yesterday, your joints, let's say it's an arm or leg, again, you want to connect it to its closest moving or rotating joint. So if it's just one joint for the torso, just the one joint, or if you have multiple, again, you want to connect it into its closest moving or rotating joint. So what I'm going to do is, first of all, I need my arm to move with the body, so let me just connect this in. So that could get connected to the same joint, or in this case, I'll connect it to the one lower maybe. So I've got my arm that's going to move around. And then I've got this piece above it that's going to maybe move independently or whatever. Maybe it's just one joint. It doesn't have to be multiple joints. But whether it's one or three or four or whatever number, the arm needs to get parented in because we need to be able to move this together like a skeleton. So that all has to get connected like we did yesterday. And then what we're going to do is connect our left and right joints. So the right one goes to the torso side. So I'm just going to parent that. And the left one goes to whatever arm component or leg component or knee or whatever it might be side. Cool. So when I'm moving my arm around, this is going to cause that to move, right? It's going to be like a little kind of actuator, kind of causing that to move around. Or if we do something like this, where we have a little kind of control to control the translation of the upper arm as well. So this is the exact same thing, except this controller controls both translates and rotates, because we can then kind of move this around and have that. So this is exactly what I just did, except I duplicated this out 4 times, spaced them out, angled them in, so it looks more complicated than what it is, but it all moves and does exactly what you need that guy to do, essentially. So it all, provided you don't animate it overextending, which you wouldn't anyway. You wouldn't have the arm going through his torso. So that's where your animation skills come in. Now you can set limits, and I did set some limits on here. So you can't, translate it too far in and too far out. I didn't set any rotation limits on this though. So that's going to be up to your discretion, although you could set rotation limits on it if you wanted to. I find if you're just careful when you're animating. Oh yeah, so setting limits. Let's talk about that next. So we have this works, but maybe I want to be able to move this around as well. So let's set up our controls. Now you could use control maker, like we would have showed you yesterday, which might for you be a better option still perhaps, because we're not really going to, I don't want to get into aligning extra nodes on top of the controls and all those things that you need to properly orient the control to the arm until after the term. We're going to do that later. So maybe I'll just use control maker. So can I type it in? Control maker? No. I'll have to source it. Hopefully it's in the right folder still. So let's see. Documents, Maya. No, it's gone. All right, so where did I get that from? I think I had it in my 2013 Maya, perhaps. There it is. All right. All right, so I'm just going to use circles. So select my 2 arm joints, or 3 if I have a wrist. And I'm going to grab control maker, so I'll use Nurbs circles. I'm going to use point and orient, so it does translates and rotates. Color code it, call it arm, snap it. They're really tiny. I'm going to undo that, and I'll do it again. I'm going to increase the scale of this, so let's go maybe 6. That's still too tiny. Let me do it again. Oh, this is actually good. I'm glad this is not working though, because oh no, it is kind of working. Okay, never mind. I was going to show you something, but it's not important. And then I'm just going to rotate this. Whoops, wrong one. There we go. And again, we can move these around, but you have to move them from the hull so the pivot point doesn't get changed. Because when you move it on a shape node level, the pivot point stays the same. All right, so we've got this working, and we've got this moving things around. But I want to be able to set limits. And this should all kind of move together, right? I want to be able to set limits though. So to set a limit, you just select your object, your controller. You want to do it on the controller, not the joint itself, because that can cause some problems. And we're going to go to the top tab, the transformation tab. And right here, limit information. So I advise don't set rotation limits necessarily, because you might always want to just kind of push it just a little bit further than that, and also it does some weird things once you reach those limits. It starts just randomly giving it values, and it just behaves a little bit weird. Translate though is good. So I'm just going to go into translate, activate my limits here. Now at the moment this is going to be way too low. It's going to be 1 unit, and I've got centimeters on, so it's not going to be anything. So what I want to do is decide, well, what is this? This is Z. So I'm going to go to my Z value down here, just turn this off temporarily, and I'm just going to go to my maximum Z value where I want that to kind of stop. So I'll round it out to maybe 23. And I'm just going to, that's a negative, so I'm going to use this arrow to shoot that value into the negative box. And then I'm going to go positive to, you know, before it kind of rips apart there. So that's about 15, we'll round it down. And I'm going to shoot that over to my positive box. And then I'm just going to turn it on now. So now when I move this around, it'll stop there, it won't go any further. And then you just do the same for all of the other axes. So, you know, when you're moving things up and down, oh, but I've got my very small limits on. So when you're going up and down, it doesn't rip apart, because it's not going to rip apart this way, but it might rip apart up and down or front and back. So again, you do the same thing. You kind of go kind of as high as you would perhaps. Now it really depends on how close to the object it is, right? So maybe you don't want to set a height limit, because that's going to really vary depending on the distance from the object, right? Because, you know, 5 units out here, it's going to rip apart. But if I go closer, 5 units up, I could go maybe 8 units and it won't rip apart. So it really depends. So
you are modifying one control for one piston now?
No, this control controls all pistons. So for example here, this controller is going to be controlling all of them at the same time. Right? Because the pistons are angled and positioned properly, this controller is controlling everything together.
So when you set the limits, you set the limits for
the controller.
Just one time?
Just the one thing, yeah.
Okay.
And then you just have to be careful when you're animating. So, you know, if things start to rip apart, maybe don't go as far,
Yeah.
which is pretty easy to do, I guess, right? So that's your skill as an animator, which is why you make the big bucks as an animator, is to Make sure things don't look broken. That's part of it anyway. That's a big one. Or staying on model. And for the most part, that within limits, that's going to work pretty good. You know, you can't, depending on the angle, push in too far. Otherwise, you know, this starts going through on the bottom, perhaps. Maybe I could set the limits a little bit different, maybe, but you know, you might want, depending on, it really depends on the angle in order to, on how far I can go in. Now, you know, we could go and be super crazy, and we could actually set limits.
For the rotation.
Well, not just on the rotations. Well, that in itself will just be as limiting as setting limits on some of the translate values. But we could set, yeah, so for example, you know, here, once it rotates past, well, let me just get this clean. So I'm going to zero that all out. Oh, but not the translates. Actually, yeah, just everything. So 0, it's a controller. So that's translate Y, for example. So translate Y, yeah, so maybe some of these we could set limits on. So translate Y, after 40 degrees, it starts ripping apart. And, you know, closer to about -8, well, after -13, it starts going through.
Also depends on the translation of the set.
Right, exactly. So if I'm higher, I could rotate that further before it goes through, right?
Yeah.
So, yeah, so
Maybe not touching there.
I would just be careful. Just, and you'll see it right away when you're posing things out. I mean, this does have a fairly large range of motion because of the way they built the toy in the first place, so that you could actually get a fairly large range with the way the pistons are all connected and whatnot. But you just have to be careful because, you know, it's not real, so you can, without limits there, you can, you know, rotate this around indefinitely. And so you just have to be careful when you're animating. But that's pretty straightforward, right? Makes sense. You just got a joint for one side, joint for the other, and you just parent to its respective body joint, essentially, whether it's the arm or torso. Let's take a break.
Can you explain the cable?
Cable. Yeah, okay. We could do that now. Or how did you do your cable? Did you have a Nurbs curve through it, or did you just extrude it out? Okay, well, we'll do it that way. Okay, sure. So let me extrude out a cable as well.
I make 2 pieces of geometry like that, and then a bridge between them.
And then what, sorry?
A bridge.
Oh, that's good thinking. That's very good thinking. Let me go lower though, lower res. Whoops, not higher res. Whatever, it doesn't really sit right on the joint anyway, that's close enough. And then, let me just do this guy. All right, so let me just do that. So delete these guys, I'll combine them. Combine them, and I'll just do a bridge. No, which was that, a linear bridge? Which one was that? Let's see. Probably a linear. So let me just do it again. Just has to reset all my settings. So bridge tool, option box. Oh, that's a different bridge tool. I'm going to use this guy. So bridge, option box. And just let me shape it a little bit with the curve that got generated. So I'll turn everything off and grab this guy. There it is. I'll just fix that. All right, and then what I'm going to do is go to object mode. Oh, turn this back on. Edit, delete by type history. Just get rid of the curve. And then this guy, let me just do. Enough. And let me just get rid of the caps here. All right, so we got this. Now you could technically just bind it, and then, you know, but the problem with that is that you're going to get some weird deformations when it's bending and moving. So there's a couple of things we could do. We could, well, there are a few things we could do. We could use spline IK through that. I don't want to really get into that at the moment. Might be an option though. I was thinking just using a wire tool and then binding the wire, and that way we're not going to lose any kind of shape on the actual geometry. But we would need a wire to begin with, which is basically a curve that goes down through the middle of the geometry. Now the problem though is that you'd have to actually get something going through the middle of the geometry, and it's finding that central point. And I don't think there's any tool that will allow us to draw a curve that runs directly through the middle of something. So instead what I might do is select one of these curves on the polygon surface, or sorry, not curve, I should say edge. And there's this option here under modify. There's this convert section at the bottom of modify, and it allows you to convert a lot of different types of objects into a lot of other types of objects. So I can, for example, convert a polygon edge into a Nurbs curve if I wanted to. So I can go to, again, modify convert, and I'm going to do just that. I'm going to select my edge. I've got the edge selected, and I'm going to convert it to a Nurbs curve. There it is. And I'm just going to take that Nurbs curve. So let me just go here, modify center pivot. And I'm just going to shift that a little bit more into the middle of the geometry. And that should be pretty good. All right. Now there's this thing, a deformer called a wire tool. Basically, it lets you change the shape of an object with a curve, essentially. So what I can do is try this. Let's try this first. But before I do, I'm going to have to delete history, freeze trans. All right. So what I'm going to do is I'm going to go into my Nurbs curve. And if this doesn't work, we'll just use the spline IK, because that might give us a better result. But we'll see. This could probably be good enough. So create deformers. And we're going to go to what's called the wire tool, which is right here. And go, there we go. So what you have to do is select the wire first, then hit enter, and then you select the, oh wait, let me see. Let me do this again. Wire tool, so select the geometry, hit enter, and then click on the wire, hit enter. There we go. Geometry first, hit enter, wire, the curve, hit enter. You have to hit enter twice. And then you get, did I do it? Yeah, I did. And then you get this input under the geometry here. So it's not going to look so good as a default, but if I move my wire around here, it's going to start moving elements around, which it's not. Let me see, is there a connection? Yeah, there is. which is not really moving at the moment at all because my scale is so large in my scene. So this is, don't forget, based off of units. So I got this guy here. Let me just zero this back. So if I go into the actual wire tool, we've got this thing called drop-off distance, which is in units. So you just want to go quite high with that. Let's go 50 at first. So now when I move this around, this should stick and move exactly with that wire. And if I grab any of these verts on the wire, this is going to move around with that as well. Now this curve, because it was extracted from the poly, it might be too dense. There might be too many vertices there. I probably don't need quite so many. So what I'm going to do is I'm going to minimize that. So I'm going to go into, I can do it a couple ways, and I probably should have done it first, but I think I can do it after. So what I'm going to do is I'm going to rebuild this. So I'm going to go to, with the curve selected, edit curves, rebuild curve, and I'm just going to change this. So right now if I go into my attribute editor for the curve and go into my curve shape, it's going to tell me how many spans that curve has, which is 13. 4 might be too few, so I'm going to just go with half, roughly, so 6, and go apply. Yeah, so that caused my wire to get all kind of gunged up. So I'm going to do this again. I'm going to detach the wire tool. So I'm just going to delete history on that. So modify, delete by type history. Or sorry, edit, delete by type history. And I'm going to rebuild that curve. So let me do that. Rebuild the curve. There we go. So now it has fewer points to control. So I'm going to do this again. So the wire tool is create deformers, wire tool, hit enter because the geometry is selected already. Select the curve, hit enter. There you go. In wireframe, you can see how the geometry turned pink when that curve was selected. That means the connection's there between the two. And again, so under the wire, we're going to go and increase the drop-off significantly. So now we have fewer points to control that mesh. Now, what we can do, though, is we can take this curve and bind it. And the cool thing with this is that my geometry is not going to lose volume. So it's not going to pinch when things get bent and stuff like that. So even if the curve gets bent, my tube will maintain its volume, essentially. So what I can do is I can select my two joints I want to bind that to, which I have to turn on. I can select that curve, and I can bind that just using the same skinning methods we used the other day. So now when I rotate this, it's going to rotate. My tube's not going to get all kind of weird and deformed and kind of out of shape. It's going to stay and be tubular still. And everything should stay together, which it is. Cool. And that's all working. Awesome. Now let's get a coffee. All right, so let me pause that. So that works. And then we could try making that curve dynamic. But that's another day, perhaps. And that's another day. All right, so let me pause that. Or stop it.